Let's convert that pixel position to a discrete coordinate within the world space of our renderable region. Pixel x to discrete unit x. First thing we need to do is bounds check to make sure that the pixel is within the VP0, the on-screen viewport. If it's not, we will set the discrete unit x to 1 outside of the bounds of the DOM. Otherwise, we're going to calculate forward using VP0 and then undo those calculations using VP1 to get the discrete location. We take the width of VP0, we get a position along VP0, we use those two variables to get a percentage along path. We then get the width of VP1, and we can undo that percentage along path and get a linear integer value of VP1 pos, which is 0-based, and we can add that to the left anchor point of VP1 to get our discrete units x, and then output discrete units x here. The math for the y is the same idea. It's just the y-axis instead of the x-axis. So bounds check. If we're out of bounds, we're going to set it to 1 outside of the bounds. We work forward with VP0, and then we algebraically undo our calculations using VP1. And that's how we map a coordinate pixel x on VP0. We map it onto VP1 doing that. I'm not going to describe the math here because it's the same math, it's just the y-axis. We'll output the discrete unit y down here. What we did previously, some footnotes, and what we did in this video. We just finished those two formulas. You have been on video number 146. If you don't think I went into enough detail, you can go here for more detail. Like and subscribe.